Hi, Abby, how are you?
I'm good.
Hi, Nana, how are you?
Good.
So, any question from your school? Let me answer it first before we go for anything else. Any question?
Not really.
No? How about Nana? You have any question?
No.
No? Okay, no, then we will not take care of it, okay? Today we will be working on our chapter 3, the data collections, okay? So let's get started for this data collections. So last time we briefly talk about program structures. We give you a basic program structure, but later we are going to actually redo it again in more detail. But right now we just go over the language once, okay? So chapter 3, we will go over the data collections. That's another topic, how your data got organized, okay? How your data got organized. So basically, there are several built-in, okay? There is a word called built-in. Built-in means the standard. When it comes with the Python language, it already has. That's called built-in, okay? So there are some standard and built-in data structures. Okay, these you need to keep in mind, okay? These have string, tuple, list, set, and dictionary. These 5 things you must keep in mind. But how to remember them? Okay, how to remember? Number one, string. String would be something in double quote, A, B, C, D, E. Okay, or single quote, A, B, C, D, E. Or triple quote, A, B, C, D, E. Okay, triple quote. So single quote, double quote, triple quote, they all call it string. Okay, string is a collection of characters. Okay, what is a character? Character is a letter. So first, let's talk about character. So what is a character? Character is a letter, okay, such as A, B, C, D, E to Z, okay? So a single character, sometimes we also have something called ASCII code, okay? So ASCII code is, we call it American Standard Code for information exchange. Okay, so that is some kind of standard for the characters. Okay, this is some kind of standard for character. We call it American Standard Code for information in inter-exchange. Let me put it in the group. Okay. So where can we find this ASCII code? It's ASCII code, okay? ASCII code. ASCII code, you can search the internet, okay? And you search it for internet code. Let's call it 8-bit ASCII code, okay? This one in AP, it will be tested, okay? You must remember what is ASCII code. In AP, it will test you this ASCII code concept, okay? You must remember, okay? This one you must remember. Let me find a good table for you. A good ASCII code table for you. You need to remember, okay? One moment, okay? Let me see. There is good table. This one is a good table, okay? This one is a good table. Let's copy this one. So you must download these tables, okay? This is called ASCII table. So this one is called A-bit. When you don't know about it, you can search in internet, okay? American Standard Code for Information Inter-Exchange, okay? So this is called ASCII code. Okay, it's called ASCII code. And then this table. This table also very important. Let's also get this table. Okay, this table is ASCII code table. Okay, number one, the first table. Let's look at this second table. Okay, this second table. Let's look at this second table. This second table tells us AV later, okay, such as A to Z. Okay, A to Z. These are characters. These are English letters, and hexadecimal and the decimal. Okay, so hexadecimal is 16 based. Okay, decimal is 10 based. Now, what is 16 base? What is 10 based? Okay, so 10 base is 65, 16 base is 41. Okay, that means a letter A. Okay, a letter A. A letter A is stored in computer as 65 as decimal number. Okay, if it is hexadecimal, it will store as 41. Okay, and then it is a binary. It's stored as 000000001. I'm sorry, this one should be 01000000. Okay, this is 4, this is 1. If you convert it to hexadecimal. Okay. Okay, we have a few words: decimal, hexadecimal, and binary. These are something we need to learn right now. Okay. So these are something we need to learn right now. So these are the format of the data that you store a single letter A in computer. Okay, that's the format that you store a single letter A in the computer. Now, computer is, we call it binary computer. Okay, so when we go to the basic computer storage, all data are stored in either 0 or 1. Okay, this we call it binary. We call it binary. Okay, all data are stored as 0 or 1, so we call it binary. Okay, we call it binary. And such a basic unit, we call it a bit. You can store 0 or you can store 1. Okay, this we call it binary because this bit is actually bit is binary digit. Okay, a single bit is binary digit. And then we may have a bit. Okay, we may have a bit. So a bit. Okay, a bits. A bits, people call it a bits, but later they call it bytes because this word sounds like byte. But byte here, this I actually sound like it's biting something, right? Biting something. So they don't like this word, so they change it to BYTE. So when a bit, we call it 1 byte. So a bit you have 0, 0, 0, 0, 0, 0, 0, 1. Okay, for 1. This is actually 4-bit here, 4-bit here. We call it 1 byte. So when you actually buy a computer, they tell you this computer is how many megabytes, how many gigabytes. Okay, so these are the bytes. So single bit, single 0 or 1, we call it a bit. And then 8 bits, we call it a byte. But usually memory is sorted by the number of the bytes. Okay, so far okay? So far okay?
Yeah.
So now let's look at the binary numbers first. Okay, what is a binary number? So your 0, we call it 0. Okay, binary. This one is decimal. Okay. Your 1, binary is also 1. Your 2, you can only have 0 and 1. So you actually carry 1 bit to the next bit. So it becomes 1, 0. Your 3, you'll be 1, 1. 4, you'll be 1, 0, 0. Okay. 5, you'll be 1, 0, 1. Okay. 6, you'll be 1, 1, 0. Okay. So 7, it will be 1, 1, 1. 8, it will be 1, 0, 0, 0. 9 will be 1, 0, 0, 1. 10, it will be 1, 0, 1, 0. 11, it will be 1, 0, 1, 1. 12, it will be 1, 1, 0, 0. 13, it will be 1, 1, 0, 1. 14, it will be 1, 1, 0, 1, 0. 15, it will be 1, 1, 1, 1. Okay, so 4-bit, you can store the data for actually 16 different numbers from 0 to 15. Okay, so 4-bit, you can store data 4 bits. You can store 2 to the power 4. Totally 16 number from 0, 1 to 2 to the power 4 minus 1. This one is 15. Okay, so from 0 to 15. Totally, you can store from 0 to 15. Okay, this we call it binary numbers. Okay, this we call it binary numbers. Now let's look at this. Okay, let's do this. Okay, let's do this. Let me actually. One moment, okay. Okay, hello. Let me see. I'm trying to highlight my cell. Okay, this one, okay. So you can see me, right? I have a hand. So this hand, how many number I can count by my hand? Single hand.
5.
5. So you 1, 2, 3, 4, 5. How about Nana? How many number I can count by your hand?
5.
Okay. This one actually you are every number you actually have 1 finger, right? So that's 5. But if you use binary, this is 0, 1, okay, and then 2, and then 3, and then 4, and then 5, and then 6, and then 7, and then 8, and then 9, and then 10, and then 11, and then 12, and then 13, and then 14. So this one become binary system. So it will be able to count 32 numbers. If you use my number system, I have a hand. Every finger is a bit, right? So this one from this here to here, every finger can be 0 or 1, 0 or 1, 0 or 1, 0 or 1, 0 or 1. So the number can be 2 to the power 5 from 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1. This is 0. This is 31. Totally 32 numbers. That's a single hand that can represent so many numbers. So our binary number is similar to this, okay? In your computer, it stores something like this. So now let's look at our number system. Number system that you use when you are little. You go to elementary school, you learn math. Okay, so you may have 4, 5, 7. This is the 100th place, 10th place, 1st place. So this one we call it place. Or sometimes we call it weight. Okay? This one we call it value. So the real value is this one times 10 to the power 2 times 10 to the power 1 times 10 to the power 0. You've got 400 plus 50 plus 7. That's the value you got. Okay, so let me talk about it one more time. This single one, we call it a place. This every place have a value. So 1st place is 7, 10th place is 5, 100th place is 4. So you times this different number, you got this. This is called decimal number. This is called decimal number. Decimal is base 10. Okay, whatever I'm talking about right now, AP exam will test it. Okay, your AP final AP exam will test it. So far, okay.
Yeah.
Now, this is called decimal number. But if we are using binary numbers, and we have 1, 0, 1, 0. This one, this place is 1's place. This is 2's place. This is 2 squares place. This is 2 cubes place. So we times 1, 2, 4, 8. This one end up with 0 plus 2 plus 0 plus 8. This is 10 in decimal value. So now we write 10 and 10 here. So equals 1, 0, 1, 0 binary. Any questions so far?
No.
No.
So these are the numbers that when the numbers store in computer, they are stored in this way. When we say there is an integer, there is a number we store in computer in this way. Okay, but how about letters? How about letters? Characters. A letter. So letters, when they try to send the message, emails to someone else, they invented this table called ASCII table to send it. So A, they will send it as 0, 0, 0, I'm sorry, 0, 1, 0, 0, 0, 0, 0, 1. This is 4. Okay, this is actually 1. If we use a base 16, okay, base 16. Base 16, we call it hexadecimal. We'll talk about hexadecimal later, okay? But just remember it's called hexadecimal. So it's actually is 4-1, okay? But if you convert this one into decimal, so decimal would be 65, okay? Decimal would be 65 because this one is 2 to the power 6 plus this one 2 to the power 0. So it's 64 plus 1 equals 65. Okay, that's the decimal value you have. But this A as email is sent out in this format. Okay. So this actually a single A when they send by the email is something like this. So if you look at the electricity wave is 0, 1, 0, 0, 0, 0, 0, 0, 1. Okay, so it's 0, 1, 0, 0, 0, 0, 0, 1. Okay, that's the ASCII code is sent out to your computer if it actually using electricity to send it. Okay, this is the code ASCII code. So ASCII code is used to represent data, to send the data, your text data, okay, to set your data. So let's go back to the idle, okay. So let's go back to the idle. So here I may have a letter A, okay. So that's true. A equals letter A, okay. And then I say order of A, it'll give you 65. So this is the ASCII code. So a single letter A, you want to convert it to its ASCII code. You use a function called order, O-R-D-E-R. Okay, so order the A, you got 65. Okay, you got 65. So this is the function called, let me make it smaller, okay. This is a function called order function, okay. If you actually convert your ASCII code, your letter to a number, okay, that's called ASCII code. It's in decimal format, okay. The number is in decimal format. Now let me clear it. So if I want to have a character, okay, this character is A is actually let's see, A is called CHR of 65. Then let me print CH. You will get A. So CHR convert a number back to a character. So you have 65, you want to convert it to a character. You use a function called CHR. CHR, of course, is character of 65. You got an A later. Okay. So these are the relationship between ASCII code and the symbol in the language. Okay. And we will need it very often. And do you need to learn this in the AP exam? Yes, the AP CSP will test this. Okay. So far, okay.
Yeah.
Okay. Now next one. Next one, we are going to teach you the from decimal to binary. Okay. If I want to convert a decimal value to binary value, then let's assume that we want to convert 11, convert it to binary. How can I convert it? Okay. You use this one called successive division. Okay. So 11 divided by 2, how much? Nana, how much? Hi.
And it would be 10 with a remainder of 1.
11 by 2.
5 with a remainder of 1.
So 5, remainder 1. Put the quotient here, remainder here. Okay. So 5 divided by 2, how much?
2 remainder 1.
2 remainder 1. 2 divided by 2, how much? 1 remainder 0. So you read from here to here, it is 1, 0, 1, 1. This is its binary number. Is okay? So your 11 equals 2 times 5 plus 1. Your 5 equals 2 times 2 plus 1. Your 2 equals 2 times 1 plus 0. Okay? So let's see. Let's put this one back to this 2. Okay, so 5 equals 2 times 1 plus 0 plus 1 equals 2 to the power 2 plus 0 times 2 to the power 1 plus 1 times 2 to the power 0. Okay, put this whole thing back to here. You got 11 equals 1 times 2 to the power 3 plus 0 times 2 to the power 2 plus 1 times 2 to the power 1 plus 1 times 2 to the power 0. This is the number here. If you look at its coefficient, 1, 0, 1, 1. This is the proof. This is the proof that is a successive division can convert a decimal value to a binary value. We call it successive division. Continue to divide until you can no longer divide. Any questions so far?
No.
This one you have to remember. In the AP, they need you to convert some number into binary for sure. Okay, for sure. So let's see, this time let's try a number 49 divided by 2. 24 remainder 1 divided by 2. 12 remainder 0 divided by 2. 6 remainder 0 divided by 2. 3 remainder 0 divided by 2. 1 remainder 1. If we from here to here is 1, 1, 0, 0, 0, 1. 1, 1, 0, 0, 0, 1 times 1 times 2 times 4 times 8 times 16 times 32 is 32 plus 16 plus 1. You got 49. That's how you convert a decimal value to binary and then binary back to decimal. Any questions so far?
No.
Now that you guys practice one thing. No question, please. Okay, finish this one and type to the chat box. Okay. So now try 57 by yourself on paper. Convert it to binary. When you finish, type to the chat box. Banana, are you okay?
Yeah.
Okay, so this one, if you divide by 2, okay, you got 28 remainder 1. Divide by 2, you got 14 remainder 0. Divide by 2, you got 7 remainder 0. Divide by 2, you got 3 remainder 1. Divide by 2, you got 1 remainder 1. So it's 1, 1, 1, 0, 0, 1. Okay? So that's the solution. Okay? Now, this one is 2 based. If I want to convert it to hexadecimal, okay, if I want to convert it to hexadecimal, so 57 divided by 16, right? It will be 3. 3 times 16 is 48. So it would be remainder 9. So it would be 3, 9, base 16. Okay? And then 9 is 1, 0, 0, 1. 3 is 1, 1. 0, 0, 1, 1. So this becomes binary as well. It's a binary. Okay? So this one is you actually every 4-bit in binary. Every 4-bit in binary can be grouped into a hexadecimal number. Every 4-bit in binary can be grouped in one hexadecimal number. These will be tested in AP, okay? This will be tested in AP. So let's go back to the ASCII code table now. Okay, let's go back to the ASCII code table now one more time, okay? So right here, I'm sorry. Let's go back to the ASCII code table. Now, let's go back to the ASCII code. Let's assume that we actually look at this one called G, okay? G actually is 103.67 hexadecimal, okay? So G is 103 is hexadecimal, 67, 6 is 01007 is 0111, okay? So that is the 67 hexadecimal. And this is binary format. It's a binary, binary. It's a hexadecimal. Hexadecimal is 67, okay? Decimal is 103. That's converted. Okay, so this one is times 1 times 2 times 4 times 8 times 16 times 32 times 64 times 128. Okay, you got 64 plus 4 plus 2 plus 1. Let's see, actually, it actually, oh, this one, I'm sorry, I'm missing the 32. This one I'm missing. Is 6 right here. Okay, I'm sorry. This one should be a 1. Okay. So I'm missing the 32 here. So you sum up this one. This one would be 7 right here. Okay. And then this and this would be 39. So 39 plus 64, you got 103. Okay. So basically, this is the relationship between the decimal value, hexadecimal value, and the character. Okay. The real number you send now is a binary number 0110 0111. That's what electricity will send now. Okay. Okay, anyway, these are the ASCII code. Okay, and in your AP exam, they will test these. Okay, they'll test these. Must remember, okay, let's remember how you convert them. Okay. So anyway, that's a single letter that is you actually store in your computer. Now, when we have multiple letters, okay, we can have a quote, A, B, C, whatever. Okay, that's actually a string. So we can put in this string. In a way, each one of them has an ASCII code, ASCII code, ASCII code, ASCII code, ASCII code. Okay. So now, if you actually do B equals double quote, whatever, it still work. Okay, and you do print B. Okay, you got a string. You do C equals quote, 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 something, quote, quote, quote. So single quote, double quote, triple quote, they are all strings. Any questions so far?
No.
Okay, remember this. Okay, these are the rules. So now we finish the simple part of creating a string. Okay, so now let's look at next things. Index. Okay, index. Let me create another new file. This one, let me save as if you have question in your school, you must ask, okay? Don't actually keep it for too long, okay? Now this one, let's go to this one. Let's chapter 2 here. Let's call it chapter 3. Okay, let's put in the chapter 3. This one called string. Let's call it string 1. Okay, string 1 Python. So here I'm going to put some comment. It's actually string 1 Python. Okay. So sometimes I'll write also. Okay, version. Sometimes I put a date. So 10/03/23. Okay, something like this. Okay, so you create a string equals okay. Now you create a string like this. Okay, and there's some index. So we usually put 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here I have an extra number 8. Okay, it's useful. Okay, so when we try to get this A, okay, this A actually is print. Okay, A0. So A0 means character stored at index 0. So index started from 0, 1, 2, 3, 4, 5, 6, 7, A. A not included. A don't have data. But if you do print the length of A, okay, length is a function. So length of A will calculate how long the string is. Okay, this is how long the string is. Okay, but we can also have the print. Okay, A2. This one is A2. This actually is actually 4. This is actually C, data C. Okay. Okay, so far that's actually wrong. Okay, so let me actually save and run. So you got A0 is A, okay, total length is A not included, A no later there, okay. So it started from 0, so 0, 1, 2, 3, 4, 5, 6, 7, totally 8 characters. And the A2 is C, okay. So far, okay.
Yeah.
Okay, so far, not hard, right? And then if you try to say, let's try this, let's try print A of 20. You got out of bound, you are asking for trouble. So you got red ink, okay, index out of range, okay, so that would be wrong. So this one, you got index out of bound, okay. But if we do try print A minus 1, okay. So minus 1, you get what? Abby, what will you get?
Will you get the 8 because you would go back negative?
Oh, 8? No, you got G.
Oh yeah, that's what I meant.
Okay, you got G. How could I know it's G? You have A, B, C, D, E, F, A, B, C, E, F, G. Okay, let me see. A, B, C, D. Oh, I have an extra D, I'm sorry, but it's okay. Let me put the D in as well. I type it wrong, okay, but it's okay. Okay. Regular index is like this. So if you use a negative index, you got -1, -2, -3, -4, -5, -6, -7, -8. So backward counting from 1. Your length is 8. Your length is actually 8. That's a solution length number is called n. Okay. Solution really is n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 6, n minus 7, n minus 8. Okay. because your n is 8, n minus 1 is 7, n minus 8 is 0. So basically, my negative index, you treat it like this n before it. Is okay?
Yeah.
But you can also think about it as a backward counting minus 1, minus 2, minus 3, minus 4. Okay, this must you must remember this, okay? You must remember this backward counting rule. So far, okay?
Yeah.
So let's
Yep.
try one more number, okay? Try one more. How about this one? Let's try. So let me actually put something here as well, okay? Let me put the actually minus sign. This one's A7654321. Okay, and 0. So this one is a negative number. When you need to check the index, sometimes I put on top of it. So it would be better you know that which character it is. Okay, so let's do now another one. Let's do print A minus 4. Which one it is? Nana, which one it is?
It would be E.
It will be E, okay, for sure. That's 7 wrong, okay? I'm teaching you so that you can know what is negative index, okay? So you've got E, yes. That's correct, okay? This is called negative indexing, okay? This is called negative indexing. So a single number, you will be retrieving one of the characters, okay? And then here we are talking about positive indexing. Okay, we teach you positive indexing, negative indexing. Okay, good. This one let me save. Let me save as string number 2. Okay, I'm not going to use the same file. Let me change it. So this one let me do string number 2. Okay, this time let me delete D. Okay, I'm going to change everything. So let me delete this. Okay, here I would be using A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, S, Y, E. Okay. So the index would be, this one is wrong now. So this one would be this line 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So it's up to 26, totally 26 letters, right? And again, this one is minus 26. So 6, 5, 4, 3, 2, 1, 0, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, these are the negative indexing. So sometimes we use this to help us to understand something, okay? Next one, I'm going to teach you something called slicing. Okay, slicing. So what is slicing? When we have the A, and then we have S, E, and J, 3 number, okay, 3 number. We use it for slicing, okay? So let's see if I use print A 0, 4, 1. You are starting from index 0 to 4, but 4 not included. So this E not included. Okay, so starting from S to E, but E not included. Okay, and then jump by 1. Okay, jump by J. Okay, J. Okay, so S means start, E means end, J means jump. Okay, So this one, you do this, you should get A, B, C, D. E not included. It's number 4 not included. Okay, let's try this one. Okay, A, B, C, D. Now, if I want to do from 6 to 16, but not including 16. Okay, so let's do print A 6 to 16, but not including 16. Jump by 1. Okay. Save. That's wrong. Okay, so you actually GH something to P. P is actually 15, but 16 Q not included. Okay. So it should be this one. You should get from 6 G to P. Copy. Paste. Okay, this is the substring you will get. Okay, so slicing. Okay, so slicing is used to get the substring. Substring is part of the string. Okay. So far, okay.
Yeah.
So now, one more. Okay, one more. So now next one, let's do print A04. If we only had two number, two number, it will S and E. Okay, and then J equals 1. Assume. Okay, two number. Okay. So when we see 04, it actually means the same thing as this. Mean the same thing as this. Okay. When we do print A and then 6 to 16, you also get the same thing here. When two number, it means starting and ending. Ending not included. Okay. So far, okay, these two are the same. With one or no one is the same. Okay. So far, okay.
Yeah.
What happens if you slice twice or something, not just once?
What do you mean slice twice?
I mean like jump, because you know how J is
Yeah,
jump.
I'm going to show you. Okay. So next one, let's do actually jump. Not equals equal 0. Okay, so let's do print A. Okay, 0, 4, and 2. Let's see. It's starting from 0, so we have A, B, C, D, E, F, G. Okay, let's do this. 0, 1, 2, 3, 4, 5, 6. So you say actually end at 4, right? So here, anything here will not be related. It only related to the left side. So it started from 0, jump by 2, and 4 not included. So this one, you will get A and C. Let's try another one. Okay, let's try this one. Print A. Okay. 6 to 16. Jump by 2. So we've got this one. Okay. But this G will not be there. J will not be there. L will not be there. N will not be there. P will not be there. Got it? Is that okay? jump by 2. Jump by 2. The jump number is jump by 2. Okay. Okay, these are the basic one. Let us try some more advanced one now. Now, how to say first 10 numbers, 10 letters. You'll be print, okay, A, 0 and 10, okay? So 0 and 10 will be 0 to 9, but not including 10, it will be this. Okay? Another way to write it is that you do print A nothing 10. When you say nothing 10, so the nothing means 0. Or starting of the string. This is the same as the previous one. These two are the same. Is that okay?
Yeah.
Let's try. Okay. If you say, okay, this is first 10 letters. But if I do this, if I do print A nothing, what will happen? So you start from 0 and at the end of the string. So first nothing means 0. This second one ending means the other end. So this is actually A nothing means the same string as A. No change. Is that okay? It's A to G. Any question?
No.
Okay. Now, if I want to say how to say last 5 letters. How to say last 5 letters. Okay, this one. Anyone want to try?
Can you scroll up so I can see the letters again? Like the list.
A to G, just A to G.
Yeah, for the numbers. Would it be
So this is from V to Z. Okay, I'm not asking you this. I'm asking how to use the index to say. I'm not asking for the answer here.
Oh, okay.
I'm asking for the index.
So you would start at the last, like the last fifth one, like
So
the
you do length of the A minus 5 column, right? Your string is actually the last 5 letters. So this one's -1, -2, -3, -4, -5. So this is minus 1, the length of the A minus 5 to the end of the string. So second one, you leave it open. Okay. So two number. Okay, I'm good. So this one actually you get the V W X Y Z. Okay. Is okay. But if you do this, if you point A minus pi to the end of the string, you will get the same V, W, X, Y, Z. Does that make sense?
Yeah.
And Nana, are you okay?
Yeah.
Must remember this, okay? This is more advanced Python technique for slicing. So in a way, let's actually put it here, okay? In a way, you do have a three number, okay? Three numbers. So let's see, if you have A, okay, and then you have this, okay? So this one, okay? First missing, first nothing means the start of the string, 0, okay? Second nothing means the end of the string, but not including, okay? But not including. So it actually should be length of A, okay? And then third missing, if you have three numbers, third missing, third nothing means 1. Okay, but usually when you have a third missing, we just use two numbers. Okay, we just use two numbers. We don't need to use the third number. Okay, but remember to use the negative number well. Okay, so let's see if I want to cut 2 letters out from my string and 2 letters out from the end. What should I say? So this one is -1, -2. This one is 0, 1, and 2. Okay. So if I want to say this one from here to here, this string like this, cut 2 letters out from beginning and cut 2 letters out from the end. Okay. So that's the cut 2 character from head and the tail. Okay. This one you would point A2 to -2. Okay. 2 means you starting from 2. -2 means this -2 not counted, but it's the end of the string. So cut 2 letters out. Does that make sense?
Yeah.
Okay, let's try. Okay, let's try. And this is slicing applied to list or tuple or set or anything that Python do. So this slicing is universal. Any of the compound data type, they will be the same. So this one AB got cut out, YG got cut out. Okay. Any questions so far?
No.
No.
No. So now let me actually try another one more advanced. Okay. Reverse of the string. I want to reverse the string. A now. How can I put a 3 number in to reverse the string? Three number. And I want to make the A to Z reverse. So I started from the last letter to the other end of the letter, and then A1 jump by -1. So jump by -1, it will go backward. See. Okay, that's wrong. This one from G back to A is the reverse of the string. So jump by -1 is going backward. Okay, now let's see. If I want to do PONM, what should I do? E is 15, L is 11, right? So we do this, we do print A 15 to 11, okay, jump by -1. We started from from P to M, PONM, from 15 to 11, 11 not included, go backward -1, okay? This one you should get PONM. Okay? So these are the art of the slicing, okay, how you get part of it. But when you have only one number, you are going to get single character, okay? Slicing is for 2 index or more, or 3, okay? If you don't have only have 2 numbers that's only starting and ending, jump by 1 by default, okay? Okay, and if your first number missing, that means that it's starting from 0. If your last letter missing, it means that it actually is to the end of the string. Okay, these are the rules. These are rules for slicing. Okay, and this can also apply to the list. When we talk about list, it also applied. Okay. Now let's look at another one that's actually save string number 3. Okay. So here I'm going to look at string number 3. Okay. Operations. Okay, operations. So this one, I'm not going to use A anymore. Okay, let's delete it. Okay, this is string number 3. So this is string number 3. We will have A equals A, B, C. B equals C, E, C, D, E, F. Okay. C equals D, H, I. Okay, so we do B equals A plus B plus C is called, let's put it on top, concatenation. Okay, connecting everything together. So let's print B. Okay, so this. If I do repeating A for 3 times. Okay, repeating for 3 times. Any questions so far? These are operations. Any questions so far?
No.
No. Sometimes I will convert a string to list. So I do list list A equals list of A. Okay. Okay. Now, if I want to convert list back to list of the character back to converting list of character back to string, I have this A. Okay, I want to convert it back to string. So I do this. Okay, S A equals space the join. Join what? Join this A. I can also use plus sign the join. I can also use SA comma. Okay. Is that okay so far?
Yeah.
Okay. So here I'm teaching you what? Concatenation, repeating, and converting. So when you convert from string to list, you use this function. From list back to string, you use join function. Join what? Join by a separator here. This string is a separator. We call it delimiter. Or sometimes some people call separator. Okay. So nothing means they just connect them together. Plus sign means that in the middle of them, you put a plus sign to connect them. Comma means you, in the middle of them, you put a comma. So far, okay?
Yeah.
Banana, are you okay?
Yeah.
These are basic functions, okay? These are basic string functions. Now next one, let's do this, okay? Let's do this. Converting number to string. Okay, so you have A equal, let's do N equals 1, 2, 3, okay? So you want to convert it to string, so I would say, I would actually do this, okay? Sn equals str of 1, 2, 3. So when you print, it looks like 1, 2, 3, but it actually is a string. So let me type of the Sn, okay? Print the type of Sn and print the Sn. Okay? So convert a number to the string. Can we do this? Can we do Sn1 equals double quote plus 1, 2, 3? No, you cannot. You cannot press a number to a string. So this one not okay. Okay, this one not okay. Okay in Java, but not okay in Python. Okay, this one is not okay. Not good. So here you can only use str to convert a number back to string, okay? And from string to a number, n equals int of the sn, okay? You convert it back to a number. Okay, floating point the same. Okay, floating point the same. This one is when you need to convert from number back to a string back to a number. Okay, string back to a number. Okay, so this one will give you the basic idea of string converting back to a number or everything. Okay, so let's go back to the slides. We basically cover the majority of the string type. Okay, let me see. Let's go through the slides. Okay, making sure we do not actually forget anything. So there are several data type. Okay, basic data type you have integer, string, Boolean. We talk about it. Floating point. We talk about it already. Today we teach you the string and a little bit of the list. Okay, today we cover it so far. Okay, so string you can do concatenation using plus sign to do concatenation. Okay. And then if you want to go through the every character in a string, okay, let's use a string for, okay. Let's actually save as string for. String for, okay. This time let's actually delete these. Okay. So A equals A, E, I, O, U, okay, the vowel sound. So we do for character in A, okay, in the CH. This one will iterate through every character in A, okay. So A is a data collection, a string. It goes through every character of it. Okay, so you got A, I, O, U. You can also do this, okay? You can also do for integer in range of A, range of len of A, okay? Print A's I, okay? So you'll iterate through the same thing, A, I, O, U again, okay? In between, let's put a print, so you have separate, you'll be separated. Okay, now let's talk about the range function. Okay, range function is to actually generate a tuple of numbers. Okay, before we talk about number, let's talk about tuple. Tuple is tuple. Tuple is another collection of data, start with parentheses, ending a parenthesis. So 1, 2, 3, this is a tuple. Is that okay? So before that, let's talk about tuple. Okay, so T1 equals 1, 2, 3. So this is a tuple. So when we print it, let's separate it by a print. Okay. Okay, so you got the 1, 2, 3. Okay. So you can also do print tuple of 1, 2. Okay. You got something. Okay, the rule for slicing is the same. Okay. For rule for intersection, slicing is the same as string, so I don't repeat it. Okay. So tuple is a collection of tuple is a collection of data, okay, of fixed length. It is immutable. What does it mean by immutable? Have your teacher teach you this word?
No.
Okay, immutable means no change. Immutable means no change, no insert. Okay, so if I try to do T1 2 equals 3, I'll try this one. No way, okay? No way, so this one, no way. You cannot change the content. Okay, anyway, that's a tuple. Okay, so but range function will generate a tuple of the numbers. So now range function also has 3 numbers. It's also start, ending, and jump. 3 numbers. Okay. So now, if we only have this 3 number, also is start, ending also not included. And the jump number, okay? Same as the string. But now let's talk about range of single number. Single number means you are using, it's the same as range 0, e, 1. Okay, so let's do this. Let's do print, okay? Range 5, okay? Or print range, okay, 0, 5, 1. Okay, that's right, is 2. You got the same. No, that's actually converted to list. Okay, this one I cannot show the data, so let me convert it once again. This is a tuple, but you actually cannot see the content when you print. Okay, so let's do this. Convert it to list. I'm sorry. So let me run it. When convert to list, it will be 0 to 4. Okay, so far okay. 2 are the same. One number means only had the E number. And E not included, so it generates from 0 to 4 if you have a range 5. Any question?
No.
Now let's have 2 numbers. Range of S comma E. Okay, so let's print. Okay, list of range of 2 to 6. Okay, so this one will generate 2, 3, 4, 5, but not including 6. Okay. Okay. 2 number means starting and ending. 3 number Three number will be SE and jump. Okay, that's a current list of the range of the 2 to 20 and jump by 2. These are the even number from 2 to 20, but not including 20, so up to 18. And all even numbers. Okay, so far, okay.
Yeah.
So the range function is a way to generate a certain number in a certain range, and there are three numbers SE and J, starting, ending, and jump. The rule is very much similar to the string, the slicing in string. Okay, very much like the slicing. So here I want to go through every index of the A. So I get started from 0, go up to length of A minus 1, but not including length of A. So that's the range of this. This will go to every index of A and you print it. This one you will go to get every character in A. So these two are different. This one's every character in A. So usually this one I use the CH because for every character in A. This one is for an index, so I use I. Usually I use I for index in the range of the length of A. Any question?
No.
Can you guys stay or no? More after 5 or no?
I have to leave at 5.
Okay. So I think we cannot go too far. Okay. So today the whole chapter 3 we are not completing, but at least we go over the string and also go over the range function. Okay. Let me go through the string slices more. Okay, to finish up this string section. Okay. So that's the last one for string. That's the index and go to the for loop. Okay. So this okay, this one okay, this one out of bound, not good. Okay. And then you can calculate the length. Okay. Looping, you do loop. Okay, go into the index. Okay, we just teach you using looping. You can also for each letter, this one get every single letter one by one. So usually I use a CH. Okay. Okay, there are some function find count upper. Upper is converted to uppercase, lower to convert to lowercase. Okay, strip is taking out of some white spaces. Okay, these different things we will see it later when we go to more advanced topic. Dealing the files. Okay, concatenation we teach you already. You can do logic to check if a character in the string or not. Okay, using in operator. Okay, so you check if n is in the string or not. Okay, this is okay. String comparison. A string comparison, you compare two strings according to the first letters alphabetical order. So when we say alphabetical order, it really comparing the ASCII code. Okay. So lowercase a is bigger than uppercase a, okay, and then lowercase b greater than lowercase a, okay. So these are using the alphabetical order. But if two letters are the same, you try the second one. If the second one is still the same, keep going, and then until there is a tiebreaker happen. If there is no tiebreaker, then this one will win. It will return 2. Okay. If you tie on every letter, then the longer one win. Okay. Then the longer one win. Okay. But if you do have A, B, C compared to A, B, C, then it will be equal. Okay. Then it will be equal. So these are string comparison. Okay, there are several libraries, but today we don't touch the library. Okay, we don't touch the library. Okay, this will be for the next time. Okay, any other question?
No.
So next time we'll talk about list. Okay. Okay, no question up to here. Okay, see you next time. Bye bye.
Okay, thank you.
Bye bye.